Okay, in this video, we start talking, or we talk about the normal distribution and the standard normal distribution. We use these a lot in operations. We use these as assumptions in project management, inventory management. It shows up in forecasting. So let's review the normal distribution and the standard normal distribution. So the normal distribution, again, normality is assumed in many things. The central limit theorem, which is sampling strategies, which shows up in quality control. It's based on the central limit theorem. The normal distribution tends to show up naturally in real life. A lot of times, a lot of things happen that are normally distributed. So the normal distribution has two parameters. So just because you say something is normally distributed, that's not enough information. You also have to talk about, the two parameters, which is the mean, which is the middle, and the standard deviation, which is how much variability or how big the tails are. In Excel, we can use the norm dist and the norm INV function. To find the cumulative distribution, we can use the norm dist. We almost always set the argument of the norm dist function, this last argument, to 1. But you can see what the inputs are. You have to give it a specific value that you want the cumulative distribution. You have to cumulative probability. You have to calculate the mean, the standard deviation. The last argument is that you want a cumulative. The norm INV function helps us identify a specific x, a specific value on the horizontal axis, given a cumulative probability. Here's the picture of what we're talking about. So the normal distribution is something centered at the middle. It looks like this bell-shaped curve. If I want to find the blue area, the area to the left of this value, I use the norm.dist function in Excel, where I tell Excel what this number is. I tell Excel what the mean is. I tell Excel what the standard deviation is, and the last argument is 1. If I want to solve for this x, then I've got to tell it what the area under the blue is, the mean, the standard deviation, and it will solve for x. So let's do some of this in Excel. So this data file that I provide you has a worksheet called the normal distribution. And I can only show that this graph is only showing somewhere between, I think I can 0 and 25. So it's not something where I can play with this for any type of value. But in theory, the mean of a normal distribution can be any number, minus infinity to infinity. It can be negative. That's perfectly fine. And this just tells you where it's centered. So if I would center this at 15, it would now be centered here. If I center it at 8, it moves it. So all that the mean does is tell us where the center is. The standard deviation tells us how much variability is in the system. So if I have a standard deviation of 3, you can see that roughly this plus 3 of these is about as big as this gets. So this plus 3 standard deviations is about 19. That's about as big as it gets. There is area underneath this line, but it's very small. Let's scoot it over a little bit before we do this. And then the middle minus 3 standard deviations, so 12 minus 3 times 3, or 12 minus 9, about to the left of 3 is about as small as it gets. Now the standard deviation tells me how much variability, how big my tails are. So if the standard deviation is really small, my normal distribution gets very little area in the tails. It's still the same principle. This plus 3 of these, so 15. That's about as small. There's hardly any area to the right of this in the blue, or the 12 minus 3 of these, or 9, there's very little area to the left of this, or I can make this fairly big, and then it has a lot of area in the tails. It's wider. So that's what the two parameters do. You always have the bell-shaped curve, but the parameters tell you where it's centered and then how much area is in the tails or not. The norm.dist formula tells you what the area to the left of a specific value. So let's say I've got a normal distribution centered at 12 with the standard deviation of 3. If I want to find the area to the left of 15, so I'm centered at 12, 15 is about right there, so the blue is the area to the left of 15. How you would calculate that formula: norm.dist, you put in first your value on the x-axis, which is 15. You put in your mean, your standard deviation, that's C2 and C3, the last argument is 1. And so the area, the blue area, is 0.841. Well, that means the area to the right, the white area, has to be 1 minus, because the total area under this curve is 1. That's one thing you get with the normal distribution, because it's a probability distribution. The total area under the curve has to equal 1. So if the area to the left is 0.84, the area to the right is 1 minus that. We can always use the back of a stats book, but if you're going to use the back of a stats book, you've got to calculate a standard, a z-score. And the z-score formula is always, the numerator is the x value minus your mean, and the denominator is your standard deviation. So if I would go and look in the back of a stats book and find the area to the left of z equal to 1, what would I get? Well, I've got that here. Here's a standard normal. The definition of a standard normal distribution is the mean is always centered at 0 and the standard deviation is 1. So a normal distribution has any value here, and the standard deviation can be anything that's not negative. The standard normal, when I add the descriptor standard in front of the normal distribution, it is hard-coded where the mean is always equal to 0 and the standard deviation is always equal to 1. So if I want to find the area to the left of 1, let's put this at, make it wait. That's 1. So this is the area. So if I want to find the area to the left of 1, there's your number, 0.8413, which is the same number we had here. So you could always use the back of a stats book, which gives you the standard normal, or you could just do it in Excel. Now, the benefit of the standard normal is that we can calculate confidence intervals, or remember what confidence intervals give us. So if I want to say I want to be between -3 and 3, the area, that's what the blue is, that area is 99.73. So if I go plus or minus 3 standard deviations from the mean, the area between that is 99.73. If I do plus or minus 2 standard deviations, that's 95.45. Plus or minus 1 is 68%, around there. There's your 68. So that's plus or minus 1 standard deviation. The only thing I did differently versus this formula and this formula for the area to the left, I used the norm.dist, but just look, the only thing I did differently is that C2 and C3 are hard-coded to 0 and 1. Okay, again, the normal distribution, we'll look at examples of that, but that's what it is in Excel. Thanks.